we'll just get started and run with it. I thought that the keynote panel was good, and obviously, we kind of made a little bit of a provocative statement up front on is the edge really eating the cloud. And I think here we'll dive into it a little bit more. There's still a lot of confusion on edge, and actually, edge was kind of like a general term, in that first high-level session. So we'll dive in a little bit deeper here and get together because you all bring a unique perspective to the discussion. So maybe we'll just start with real quick introductions. Frédéric, if you we'll do around the wheel, just a little bit of background on your role and kind of what you're focused on.
Yeah, absolutely. So I'm Frédéric Desbiens, Program Manager at the Eclipse Foundation for IoT and Edge Computing. So essentially my role is to keep an eye on our 50 plus open source projects in the IoT and Edge space. And the other part is to evangelize our vision, evangelize our technologies, and collaborate with other players in the space. And it's great to be here today.
Yeah, cool, great. And Zach?
Hey, Jason. Hi, everybody. Zach Shelby, co-founder and CEO of Edge Impulse. I come from a long history of working in embedded technology, founded and was the co-founder and CTO of one of the first Internet of Things companies back in 2005 already. So I've been designing these edge things with protocols back then. Some of you might know me from work in things like 6LoWPAN, lightweight M2M, CoAP. And most recently, I've been getting into trouble with machine learning by democratizing machine learning for all of us that work with edge systems, industrial, logistics, and health, medical types of devices. And that's really exciting. Glad to be here.
Hey, yeah, Obi?
Yes, I'm Obinna Ilochonwu, but don't get tongue twisted. Just call me Obi. Yeah. Not Obi-Wan Kenobi, just Obi. IoT Architect with Schlumberger. We're the largest oil and gas service company in the world. We have an interest. Software is definitely the means to an end for us. It's not the end, and we'll be talking about that later on. And I've been working with Schlumberger for about 20 years, and we have been on the edge before it was called the edge. We were doing IoT before it was kind of called IoT. So we'll kind of delve into that a little bit more. I'm a IoT architect, which is good and bad because nobody knows what I do. So that's that's good, and it's also bad because nobody else knows what I do also. So that's also.
Yeah. And then you also have to be careful what you're good at too. Good or bad, I guess. I don't know. But, you're great. Cool. And then Paul.
Hi, I'm Paul Teich. I'm product manager for infrastructure at Equinix Metal. Equinix Metal is about a 5-quarter-old acquisition, formerly Packet. And we provision bare metal in Equinix's metro data centers. So we're in about 20 data centers now. And my role is really seems to be a theme here. We're democratizing kind of what it means for our edge. I'm in the Open 19 version 2 working groups, technical working groups. Open 19 is a hardware project now under the Linux Foundation. And so we're next to LF Edge and a whole bunch of other really neat projects in the Linux Foundation. We borrow from a number of them, and we donated our provisioning software called Tinkerbell. So Equinix Metal and my role is to make the data center portion of the edge more accessible.
Yeah, great. Yeah, so yeah, obviously, yeah, we've got the gamut represented here. From Zach, you're focused on tiny ML at Edge Impulse and a lot of constrained devices out there. And then Paul, more kind of the metro regional access data center, and Obi, like you said, the technology is the means to the end for what you guys are doing there at Schlumberger. So maybe let's talk a little bit about the nuances of edge as kind of a generic term. So Frédéric, how do you view the edge? Kind of how are you guys approaching it from Eclipse Foundation?
Yeah, in our case, traditionally Eclipse has been associated to developers a lot, right? There's the IDE that a lot of people still use and a lot of people love to hate nowadays. And that's fine. We have 400 plus other projects you can pick from, right? But really, we come at this in the perspective that Edge would really be just picking your compute and storage capabilities and applications and bring them as close to the source of the data as possible. If I go, straight to the core of the definition, obviously, when I say applications, it's not any application. Those applications have to be somehow edge native, which is something that we'll probably need to define further. But our take on this is really what we call at the Eclipse Foundation edge ops, in the sense that when you do edge computing and when you want to bring those compute and storage and other resources closer to the source of the data, you need to do this in a way that's really tailored for the edge. You don't do pure cloud DevOps at the edge, because that's a very, very different environment. And that's our take in a short version on this.
Yeah, cool. So I'll ask the group. So why do we still think so? I mean, we hear like thin edge and thick edge and near edge and far edge, and there's an industrial edge and an AI edge, and just all over. And obviously, with new trends, there's always a lot of confusion, and I think conversations like this are certainly helpful. Maybe I'll start with you, Zach. Like, why do you think there's so much confusion right now about edge?
Yeah, well, I think it's because the nature of compute itself has been changing a lot over the past 20 years, right? Like it used to be pretty simple because microcontrollers couldn't do anything useful back when I started working in the industry. And you were working with industrial PCs, right, in the field. And so it was very simple, right? You either had something in a mainframe server type environment, you had an industrial PC sitting somewhere, or you had a personal computer of some type. With the advances in 32-bit microcontrollers and 32-bit microprocessors, I think we've just had an explosion of where we can do compute, how deep, how far embedded into things. For me, right, I actually think that's an opportunity rather than a confusion. I think that what we're seeing is the movement of intelligent processing and managed connected communications for devices, just deeper and deeper into these systems. I'm sure at Schlumberger you see this, right, going beyond industrial PCs to gateways and then right down to the sensors themselves. And as we get better ways of processing data, that really becomes the key for me. Can we process data? Can we refine it? Can we do more with it at the right place on the edge? And that's pretty fluid, right? Whether we're executing workloads on microcontrollers or microprocessors embedded in systems or in a more capable device on premise, I don't think it's going to matter as much in the future. I think that will be a more and more fluid concept, which is probably a good thing. Then it doesn't really matter. I would say one final thing though. We got to think about brownfield though. This can't all be about new devices. We've got all of our customers in industrial and other segments that have to be able to make use of the compute they have out there. So we shouldn't, us technologists shouldn't just think about the new fancy thing we're gonna come out and bring. How do we deploy on today's hardware?
Yeah, I mean, Obi, you can just scrap all that stuff you guys have out in the field. Right? It's pretty much reached its useful life by now. I mean, it's just cheap to replace it all, right?
Yeah, no, the oil and gas is probably one of the most conservative industries. So there are lots and lots and lots of stuff that were developed long time ago that still making money, ain't going anywhere, but need to be managed. Right? So how do you bring that along, into the 21st century, right? It's a problem. An opportunity, actually.
Yeah. Well, I mean, that's kind of a good question. So I mean, some would argue that we've been doing edge, computing for some time. I mean, a lot of people are like 5 years ago. I've been doing IoT, since the beginning of my business, but there's kind of these evolutions of these trends, and so when it comes to edge, say out in the oil field or any of the operations that you guys work on with your customers, what's kind of new to you, Obi?
Yeah, for us, again, we're oil and gas service. So the field engineer doesn't care about microservices, edge, IoT, LoRaWAN. No, they care about getting their unit of work done efficiently, safely, and consistently. That's what they care about. They will not babysit software. If software messes up, they throw it out and they use the gateway as a footstool, right? So, so for us, I guess the new thing for us is the edge. It's not just a place to collect data and process data. The edge must be a place where compute runs, but also it's managed the same way IT manages your laptop, right? So for us, the change we're seeing now is, how do we take that compute and move it closer to that physical digital divide, but still able to do that in a way that it's scalable, it's secure, and it brings all the concepts that IT has brought to us in the office to or on the cloud to the edge. And also some of the other things we're seeing is, the oil and gas edge is so heterogeneous. So you have low power, no power, poor flaky network. You'd be surprised what 750 milliseconds we do over to your chattiness over satellite feed. We have to have legacy apps that people developed 40, 50 years ago that still need to run with modern apps. You have security issues now because before in the oil and gas, security was achieved via isolation. So if you have your username and password in the closet, that's good. But right now, as you know, that doesn't work anymore. So we're seeing the challenges now. No more about it's not really about the killer apps, but it's really about how do you take those killer apps and make sure they are run in a place that you can scale up and secure at scale. That is the challenge for us.
Yeah, the adapt. I mean, in many ways, things are becoming more and more software defined than hardware defined. Going forward, and you're seeing those practices. We should touch on kind of the intersection of the IT practices coming down and the control systems as what happens as those kind of blur together over time. But and we'll come back to that. So Paul, so you're come back to you, Zach, as well, and Frederick. So Paul, kind of coming at it from the more of the regional data center. What are some of the key considerations that you're seeing as we get into more and more edge computing?
Well, given that edge is so amorphous, right? We're all talking about what makes an edge, and for us, coming at from our perspective, it's about latency and connectivity. Okay, so being close to customers in major metros worldwide means low latency pings for 90% of the planet, whatever we measure. But it not only is it low latency pings, it's connecting to each metro to other metros and to other clouds. And so a big part of what made our acquisitions work so well is the fabric here. And so I would say there's a couple different answers based on data gravity. Okay, so what do you need to process where, and when does it make sense to send it somewhere else? The farther you get toward the field and the actual IoT sensors, the smaller your frame of reference is. They don't, even with 32-bit processors, the local sensors only gather local data. And so that data has to then come upstream somewhere to make sense in context, right? You can't actually generate a weather map at a temperature sensor. That has to go back to a data center somewhere. And so for us, it's getting that data back to the nearest point where you can do the computation that you want to at scale. And so absolutely agree that there are industrial applications, in factory. And then there's a place where you operate servers at scale to get the best efficiency and power and cooling in aggregate, right? So this is also kind of a carbon footprint story from soup to nuts. So as you get closer to the edge, you have to be aware of batteries, and you have to be aware of power supply and inefficiencies in transmitting data. Costs radio energy to transmit data from an IoT device. Costs compute energy to run an inferencing model at the edge. And so developing the training models in one place, loading those models into an inferencing engine at an edge device. We're able to do that now, and that is so cool. But it's all a series of trade-offs on energy and carbon footprint and latency and data gravity. I just kind of like named the universe, but in terms of our data centers, it is connecting everything.
Yeah,
our servers sit at the nexus of a big network, and it's that connectivity that matters.
Yeah, makes sense. Yeah, so from your standpoint, regional data centers, metro data centers, several hops to like one hop away. Obviously, it's aggregating context across a lot of different devices. And then we also, I see a question here, you know, you're going to start seeing more and more device to device communication where you start sharing context locally. But it's, you know, we're going to see, you know, there's not going to be a single answer. The other reason, is it fair to say, you know, maybe it's more regional edges are reducing download latency as much as anything than it is, you know, local area devices are helping to reduce upload, you know, bandwidth consumption and, you know, autonomy, you know, ensure autonomy, ensure privacy and security. And it really depends on whether you're on a wide area or a local area network on which edge. But yeah, so it's interesting. So Zach, like, you know, so you're representing the kind of the other end of the extreme, coming up from really, really constrained devices and starting to deploy more intelligence on those devices. You know, kind of what's your perspective on that? And then we just kind of talk about some of the challenges that you guys are seeing and use cases you're seeing for, you know, like TinyML.
Well, we've already covered the manageability and securability of these smaller and smaller edge compute units. So I think that's absolutely the case. It's something we worked on for a decade in IoT. We're finally starting to see the fruit of that. That's great. But the machine learning angle of this is actually really critical because I think it's going to change the makeup of where we do compute and how much compute we work with and where data flows. You know, in the original days of IoT, we really didn't have a good way to process information at devices. We couldn't really do a lot with sensor data. We didn't even know the context of what sensor data is useful. So what did we do? We kind of averaged it. We took some samples. We just throw it all to the cloud, right? Same with gateways. However much we've talked about gateway analytics, and we don't really do a whole lot at a gateway level. We mostly aggregate, ship everything to the cloud. The sad part of that, though, is that the cloud is not a free, endless resource, right? We realize that communications and that cloud costs, and it gets really hard to do things with data when it's just we talk about data warehouses. I talk about data lakes. I talk about data drowning, right? Where you're just getting buried in all this data. It's very hard to work with it. What machine learning is doing is moving more human expert context, right down to where the data is produced. So what we're able to do now is develop really sophisticated machine learning models. I'll just bring one of my favorite devices there. That's a Nano BLE Sense Cortex M4, right? Really, really simple device, but this can run tens of millions of math operations per second. What we're doing now is we're taking industrial knowledge, right? What are the patterns in sensor data, audio signatures, computer vision that matter for specific industrial use cases? And we're using cloud compute infrastructure to train very sophisticated models, squeeze them down. And the state of the art now lets us put them on things like this. What that does is it brings a lot of that knowledge we had to kind of work with in the big cloud infrastructure and distills it down to a simple pattern matching algorithm that runs right on sensor. And something Paul brought up, I think, is really important. This isn't it's got to be deployed right at sensor or just in the cloud. This is an entire spectrum of deploy the algorithms where you have the context, right? Where you have access to all the data points you need to produce that algorithm. And so you're going to see these as a chain. You'll do some of this at the edge, right at the sensor. You'll do some at aggregators, gateways. You'll do some at edge servers, and eventually kind of the edge of the cloud infrastructure. And I think it's a good thing because it's moving data knowledge and data distillation closer to where the data is produced. We end up with more useful information. We end up with a lot less information that has to be moved around. It just makes all of this infrastructure more valuable. But final caveat, though, is in the embedded machine learning field, the work that we're doing is to squeeze more of that into these devices so we can hit brownfield too. So that's a lot of the energy that we're putting into the industry from a technology perspective is how can we do audio on M4s? How can we do audio on M0s? How can we move computer vision from requiring a Linux-based device down to a microcontroller? And that's kind of where the quest is right now with acceleration and new compute technologies. Just how can we move more powerful machine learning down deeper into the device space? So super fascinating what's happening right now. It's an amazing time to be in edge tech.
So Zach, I got a question for you. How do you decide what to send back upstream that you couldn't do in the model, you couldn't recognize in the model, with the exceptions, I guess?
Yeah, no, that's a very good question. So in general, what we're looking for with machine learning models is typically it's classification. There's different ways to use ML, but usually it's classification. So we're looking for identifying patterns, right? Was a machine in a normal state? Is a machine going into kind of a semi-abnormal, maybe a bearing failure, right? Or is a pump acting badly because maybe there's a problem with the input into the pump? You can identify those classes. You can also identify anomalies. So we do anomaly detection as kind of part of that. So we can also tell you that, oh, we found a high probability of an anomaly. We can also have that as a feedback loop. We do log anomaly samples, and we can feed those back to the training machine, right? The data sets and all that engineering work we do. But that's like a slow process. That's not something that happens in real time. That's like log the anomalies. The engineers will go look at it next firmware cycle and go improve it. But it's all about expert knowledge, right? That's what the cool thing about machine learning is. We're really distilling that expert knowledge from the domain experts, right? The person who understands those pumps and the processes going on, they're the ones that define the patterns they're looking for, and then make use of that data.
Cool. Hey, Obi, so when you're looking at it from like an operations standpoint, you're firmly in the industrial world with the work you do at Schlumberger, oil and gas services for your customers. What are some of the considerations that you guys see that are unique? I mean, we've kind of been talking about how it's a continuum, of course, but and I think we might have just lost Obi. Well, okay, so we'll wait for Obi to come back. Maybe he didn't like my question, but see you later. Hey, Frédéric, so you mentioned edge native before. Define edge native, and I've heard cloud native, edge native. Kind of what does that mean to you guys in the Eclipse community?
Yeah, essentially, edge native is about addressing a lot of the things we already discussed in a way that is industry standard and I would say familiar to developers. So edge native means obviously you will use containers and other familiar forms of building code, right? And at the same time, you are writing applications that are hardware aware, bandwidth aware, environment aware in a way that a typical cloud application wouldn't be. You don't want to multiply code bases so that, if you're deploying on a variety of microcontrollers, for example, or if there's the possibility that some nodes have a AI accelerator plugged in or not, you don't want to write different code for all of those scenarios. So we're trying to have a kind of infrastructure that will inform the applications of what's available, and then they will be able, depending on how they are written, to take advantage of those hardware capabilities, depending where they are deployed exactly. So an edge native application is much more aware of what's around it, and at the same time it still follows the cloud native principles, you would say, being containerizable, being highly configurable, and those kind of things. And so it's using, in a way, a very familiar tool set and toolkit. You will use Go, you will use Rust, or whatever you do in the cloud, but at the same time you have to have the mindset of an edge developer where you need to take into account lots of variables and lots of things that can go bad that wouldn't necessarily go bad in a data center, right? And that's what's so critical in an approach where with edge ops, essentially the whole point is to abstract those additional complexities of the edge up to a point from the developer, and at the same time still give them the opportunity to take advantage of the great regional data centers that could be in the infrastructure, for example, or whatever special features you have in your microcontrollers that could accelerate the code or make it more secure, etc., etc. So all of that is in the scope for edge native, and it's a very wide field for sure.
Yeah. Okay, question for the group. Can you have an edge app that doesn't comprehend at all some backend? Whether it's on-prem or the cloud or otherwise, can it be completely isolated at all times? Is that still an edge app, so to speak?
I mean, edge application absolutely is an edge native in that definition. I believe that to Frédéric, but edge application for sure. In a lot of industrial systems, you actually have to design for no network connectivity.
Right.
If you have network connectivity, it might be used for periodic management, software updates, debugging and logging things, but many spaces you need to assume that this has got to work standalone.
Yeah, I think definitely, obviously, hopefully Obi can come back because he knows firsthand, out in the field, the need for autonomy. Or, I guess the question is, if you never connect, is it just a legacy on-prem app that's been done for a long time, or is it have to connect at least at some times to maybe download the latest, inferencing model or get a security patch or whatever, even though it's designed, as an edge native app to also run autonomously at the same time?
So critical infrastructure is probably a place where that intersects, where sometimes there needs to be an air gap. Yeah. Okay. If you're running a nuclear power plant, I've known folks who run, expensive electron microscopes, research instruments. They're $5-10 million a piece. And even though they air gap them, occasionally a researcher will bring in a USB drive and plug it in. and so, you can get infected from anything. And so security is hugely important. And I think that plays into the question of, how air gapped and how do you update it, right? And what are the security protocols? So today, that's to me a security question.
And certainly, go ahead, Zach.
I was going to say, but I think that's an important point, that it may also be just a problem with the way we consider updating and managing these things. We might need to use some of the edge native, methodology and tools to also be able to manage things that are air gapped, right? Provide the right interfaces for, when you do connect a management unit or something, how can you use the technology we have to securely update and manage and debug and take off logs? And we deal with this as well with machine learning tools. We have customers that do want to be private cloud or even on-prem with the training, engineering side of these tools. And that's hard. It's a hard thing to manage and deploy that infrastructure privately, but yet still make it manageable.
It's part of the benefit of private metal. So yeah, we deal with that quite a bit too.
That completely makes sense. And to me, it's essential when you pick a platform or a set of tools to work with, that they will work as well, in an air-gapped environment that they would do if you are connected to the internet. You shouldn't have to write your application differently or work differently with your platform in order to achieve that. And to me, that's really critical.
Yeah, that's one of the fundamental differences. So a data center tool set assumes a constant connection to a server, and usually the controllers call the servers. At the edge, you have to assume you're going to lose connection, when distributed out in the field. And usually it's don't call us, we'll call you. The box phone's home, ask for what it's supposed to be. And you have to be able to work through firewalls. It's a different scenario altogether. So, hey, Obi, can you hear us? I know it looks like you had to switch venues. I don't know if you're fully up. It looks like you're muted at the moment. Okay, so I sent a note. We'll see if we can help you offline getting connected. So what's we've touched on some of this, like kind of by your edge, so to speak. I mean, Paul from regional data centers, and Zach kind of more highly distributed. And then we want to get your thoughts as well, Frédéric, like in terms of what you're seeing across the spectrum. Starting with you, Paul, like what's the killer app for the regional edge?
We see a lot of different applications, but in terms of IoT, I'd have to say smart city, low latency, high bandwidth interconnects. We do a lot of work with video streams, ingress on video streams. Data models matter a lot, and so we are, even though we're edge data centers, we're not cloud. We are private data center facilities, and can guarantee a better level of security, different pricing models. And so managing a lot of data is one of the killer apps for us. Being able to send that data to other entities via our IBXs, our international business exchanges, huge benefit. So it's kind of, we do a lot of other work in IoT, but I'd have to say that's like the marquee case I can see in the short term.
Yeah, so just talking about, I'm back. Sorry, we had we had a thunderstorm here, but this is kind of, I'm going to turn this challenge into an opportunity. So this is exactly what happens to us in oil and gas. So we have a killer app. We're on the killer app right now. But the fact that I lost connection, I moved to my mobile phone, that didn't work, and I moved back to this, and it's still, I'm still be able to connect and talk to you guys. This is exactly what we want on the oil field. This is exactly what the field engineers expect. They expect life to continue going on, even though there's a network outage or power loss, and I'm able to come back and maybe lose 2 minutes of downtime, but I'm back online. So it's not just a killer app, but it's about how the killer app operates in real scenarios like this.
Yeah, that makes total sense. Yeah. What other considerations? So yeah, we've kind of chatted while you had to get restarted up. We've chatted a bit about what edge native means, and we'll get back to the killer apps for some of the other edges, so to speak. But what other considerations beyond kind of autonomous operation are you seeing? Do you see out in your line of work, out in the field?
Yes. So one of the interesting ones, and also Gartner also supported this, is that we talk about latency, network. That's fine, but regulations is going to be the big killer, right? So you have data residency issues that basically say thou shalt not move your data from A to B. So guess what? Your edge has to operate like a cloud on-prem, right? So those are some of the things, some of the challenges we are seeing now. How do we overcome those? They're not really technical anymore, but they are real. You will not deploy in X country because data cannot leave X premise, right? And so the edge has to come closer. All the processing, they say the home is where the heart is. Well, the edge is where the processing is, right? And so that has to. So we actually have to be thinking about that in our use cases.
Yeah, makes sense. Cool. So Zach, killer app for the edge that you guys are focused on.
Yeah. So for the really deeply embedded, microcontroller class devices, what we see happening right now is sensor processing, and in particular in industrial machines. That's an area where we see more and more going on. There's just an endless number of ways that can solve problems for people and just open up more functionality, right? More that we can do with more complex data patterns. So I think machine learning is opening that up in big ways. We're also, however, seeing lots of human interface stuff. You look at kind of the more wearable asset tracking types of devices. We are seeing a lot in like audio processing, voice keywords. Human interfaces with COVID are a big thing. So interacting with machines without having to touch them, that's becoming bigger and bigger. So on that more consumer side, we see a lot of really interesting applications. As you move into gateway class devices and kind of embedded Linux, the power we're seeing there in the killer app is really aggregation. Like, how can we run lots of these algorithms, right? Potentially hundreds, to do a lot of parallel sensor pattern matching, to aggregate a lot from local sensors. So if you look at SCADA, for example, using this to do like SCADA data integrations and then machine learning algorithms on that. And then to deal with video. So we do see a lot of applications, like Paul was talking about, video coming into the data center. We do with now video streams and object detection right on the camera interface, so very close to it. And that compute hardware that has a little bit more capabilities, even getting into things like NVIDIA Jetsons, right? Where we can run a lot of these parallel video streams and then reduce the need to send all the video to the cloud edge, right? We could send the context from the video, and that's a huge bandwidth saver as you come into that.
Don't need to see 5 minutes of empty hallway.
Exactly, yeah. Or even just detect the interesting bits. But those are some of the killer applications I see now. Definitely machine learning having an impact here is a really important workload for these systems. The challenge we need to solve, though, is how do we make it easy for companies like ours to get the machine learning workloads on all of these devices? And that's a challenge we have to, all of us in the edge industry have to think about, like, how do we really make it easy to deploy these workloads? And I'm not going to design an edge native app whole thing with all this intelligence around some machine learning to deploy it. No way. My engineer users want to just deploy the machine learning algorithm they develop. They want to hit a button and have it out there and working. Yeah. So we've got user experience things to work on for our developers.
I like to say, well, certainly what we do at ZEDEDA is we build the gut so you can bring the glory.
Yeah.
Um,
We see a lot of that, Zach. We see a lot of that in our, that's what you just said now. The guys don't want to think about how to deploy, how to, they want this to just work. They want the easy button, press it, and it works. Right? And value added for us, this kind of take you back old school, right? We have a client today who they have digital analog sensors. And all we did was just put a camera, because this is on the rig. And so you have to fly someone on the helicopter to go there and actually record the readings on a notepad. All we did was just put a camera, on the analog sensor, converted it to digital, and send that to the cloud. You would think that's not value added, but that saved helicopter trips to the rig.
Yeah.
So.
Yep.
Yeah, no, definitely the kind of retrofit is a huge one, like you're saying. So Frédéric, we got a couple minutes left. Frédéric, your thoughts on sort of killer app, and then I want to talk about we talk about is edge in the cloud, and we talk about edge versus cloud in general, kind of binary, and of course the edge is a continuum. But I want to come back to, do certain edges start to give way over time in favor of others as things evolve? So we'll come back to that. But Frédéric, your thoughts on kind of killer app?
So essentially, what I will say is not just my own appreciation, but comes from the market research we do. So the foundation runs 2 surveys each year. Beginning of the year is commercial adoption survey for IoT and Edge, and second half is developer survey. So we're about to launch the developer survey in a few days, so stay tuned. Now, when I look at the latest results we got specifically for Edge workloads, top one was artificial intelligence, second one was control logic, third one was data analytics, and fourth one was data exchange. So you see something that meshes quite well with what we mentioned. But what I must say in my own personal perspective is that what Obinna mentioned about data sovereignty, the fact that you want to leave the data in a specific location, is really for me what's killer, in the sense that I work in IoT and Edge. I don't have a smart home. Why? Because I don't have the time. I have the skills, but I don't have the time to build my own. And then when I look at the commercial offerings, they will all send my precious personal data about my day life habits and all of that to the cloud, and I don't want that. So if there's someone in this conference that will build me a smart home platform where I have this whole little edge node in my home that keeps my precious data and will just send anonymized aggregates to the cloud and things like that, please do so, because that's exactly where we can make a difference. In other words, Edge has the potential to make IoT much more secure if we start using it at scale in real-world deployments. And for me, that's the killer thing, because if we don't do that, we are killing the IoT opportunity for good with all of those security and privacy breaches we've seen in the market recently.
Yeah, cool. Yeah, so okay, we've got a couple minutes left, and Shannon asked a question around this notion of more and more edge devices communicating locally and kind of building this fabric where you're seeing more context built across, closer to the source of data. Kind of maybe we'll run through everyone. So think of kind of edge versus cloud being a tug of war over time. And we're seeing things like camera to cloud where more and more smarts are happening directly on the camera. And it could have a tendency to carve out the middle, So kind of run through, each of you as we close up. Thoughts on what happens over time? We get faster and faster connections, but connections cost money. We have this ongoing need for data sovereignty or privacy. Like, what do you think happens over time to, not just edge versus cloud, but which edge? I'll start with you, Zach.
Like I said earlier, I think we're going to see more continuum in this for the deployment of applications. And as we see the machine learning trend I talked about, right, enabling us to do more with data further down in, people are going to take advantage of that. It opens up a lot of new applications. It reduces the amount of bandwidth we need to send. So I would hope to see in the future that we're a lot smarter about what we process, what we send, how we make use of data. And then I'd hope that as technology vendors, right, we do a great job with our user experience in doing that, right? We make this an amazing place to deploy compute. And that's actually the big challenge. A lot of this doesn't have to do technology. It has to do with user experience, how we enable people to really make use of it.
Yeah, it makes sense. So, hey, Paul, what are your thoughts?
I think data exchange. So one, managing all those devices. Two, the data gravity of putting together the big picture, and three, being able to exchange data with other folks who are solving similar or even diverse problems. That's probably the biggest challenge on our side, is creating an environment where we can interconnect ecosystems. That gets back to what is, kind of cloud to cloud or edge to edge communication look like. I don't think we know what that's going to look like in 10 years. What we can do is foster the ecosystem to make that happen in a frictionless manner, as frictionless as we can get it. And I just want to thank Zach for pointing out that this is an asset tracker and I'm the asset. So.
Yeah, makes sense. Obi, so as someone that doesn't really care which edge, you just want it to work and to deliver outcomes. Any thoughts on the kind of the continuum and where things run? And
yeah, I think for us, for Schlumberger, you're going to see the edge is always, you're going to have more and more stuff moving to that physical digital divide. The more compute resources you can put into that physical digital divide, the more it happens. So you're going to see that. I think you're always going to see the cloud, because you do need enterprise data. You do need that higher level context there. So you're going to have those two things. What I see is going to happen, I think the cloud is going to move, some parts of the cloud are going to move closer to the edge, and that's what I see. But I think you're going to have the edge, the cloud, and I think you're going to have that continuum where a lot of the cloud practices and cloud technologies are going to come closer to the edge for on-prem, for data security issues, for regulations. You're going to see that coming. So I don't think it's going to be a cannibalizing. I think you're going to have those two extremes, and then that continuum where some cloud stuff is going to move closer and closer to the edge.
Yeah, makes sense. Closing thoughts, Frédéric?
Yeah, I don't think we'll see one specific answer that will be universal for everyone coming there. As you mentioned, as everyone mentioned, this is a continuum, and depending what market segment we'll see, there will be different patterns emerging. For example, in gaming, you want to minimize your ping to the server as much as possible. So there, great data centers like Paul is working on are key to deliver that kind of capability, for example. And on the other hand, if I think about what I see in my community, at Eclipse, we do lots of industrial automation and things like that, and then obviously there will be a premium on intelligent microcontrollers or machines with built-in processing capabilities, and you will try to cram as much of the processing as possible there. But to me, when I consider everything, whatever market segment, whatever topology you consider, the winners, so to speak, as far as I consider the tools and platforms available, will be the ones that are built at least on an open source foundation. Because if you are in the platform business and you think that you can, reinvent the wheel, starting from the ground all the way to the application layer, you're wasting your time. You won't be able to create the kind of proprietary business model that some of the incumbent SCADA players in the past have created with their proprietary protocols and all of that. So whatever you pick, ensure that you do it at least around an open source foundation. And I think you will be in a good place, because whatever the market goes to, you'll be able to adapt to that. And at least I'm certainly not objective about this, but I think open source is the way.
Yeah, avoid undifferentiated heavy lifting.
Exactly.
We'll talk about this, tomorrow during the developer track. We've got a good panel set up, but I always say you make your money on the IDIs: security, manageability, Zach, to your point, usability, scalability. Not reinventing the middle, but and speaking of, so basically, the consensus is it's a continuum. We need to move more, cloud native principles closer and closer to the source of data to give you that abstraction and the platform independence and the flexibility, modularity, the ability to continuously innovate through software defined infrastructure. You can kind of call that, edge native apps that are also location aware. And there's some kind of unique considerations, of course, around autonomy. We had the perfect example of the challenges with connectivity, to the back end. But and it's a great segue. So we coming up next, we have a panel on architecting for edge success. So we're going to dive deeper into some of those types of topics. I really appreciate you guys joining, and a great discussion, and we'll keep up the conversation throughout the rest of the event.